Here's section 3.2. I hope that this little video will help you to get this concept better. This section deals again with finding zeros. And let's do not forget why we want to find zeros. This whole course is about functions. Functions are fun because we get to draw them. And we want to draw them as accurately as possible. And in order to do that, we need to find things like the vertex, the y-intercept, and also if that graph crosses the the x-axis, where does it cross the x-axis? Because that is where y becomes 0. So we're going to use some methods, and we're going to learn 5 different methods to finding those zeros. That's how important they are. First of all, let's remind ourselves what kind of function generates a parabola. And that's a quadratic function or the squaring function. And this is what standard form is. ax squared plus bx plus c equals 0. A cannot be 0 because if a is 0, then ax squared, of course, becomes 0. And then we no longer have a quadratic equation. So this is standard form, and when you begin, you must have it in standard form. So this is just a simple definition of what a quadratic function is. And remember that it can be written in that form. And then remember why we care. The zeros of this are the solutions where that has either non-zeros, so it's going to actually cross the x-axis, or where the imaginary zeros are, so you can kind of get a feel for where it might turn, because it's never going to touch the x-axis. We're going to go over this super quick. It just means if you have any two numbers in the world, and they equal 0, then one of those numbers had to be 0. Either the A number had to be 0, or the B number had to be 0. And when you multiply them together, then your answer is, of course, going to be 0. So I can say 3 times 0, and that's 0. Or I can say 0 times 7, and that's still 0. So one of the two has to be 0. And why do we care about that? Because we're going to take some binomials, some things that look like this, and it's going to equal 0, which means either this whole thing has to be 0 or this whole thing has to be 0. And that helps us find our zeros, which is what we're looking for. Another word for zeros are roots or solutions. Here's another little simple thing, the principle of square roots, that simply says if I'm solving for x, and you do that when you have only 2 terms perhaps, and I'm solving for x, I'm trying to get that x by itself. If you have to physically draw in a square root in order, like in this case, see, we're trying to get the x by itself, it's being squared. How do you undo squaring? You take the square root. So I have to physically draw in a square root to get that x by itself. And if I have to do that, then your answer is going to be the plus or the minus, and then the square root of whatever this number is over here on this side of equal. Okay? It always must be a plus and a minus. So if you have something like x squared is equal to 25, and I need to solve for this x, it's not by itself, so I need to take the square root of x squared, and I need to take the square root of 25. I had to draw in that square root. Now all that square root does is undo the square. So now my x is by itself. But if I do that, it is either going to be a plus or minus, and the square root of 25 is 5. So this is going to be either a positive 5 or a negative 5. And remember what that means. That means on your x-axis, your graph is going to cross at both of those places, at both 5 and negative 5. Here's a quick example, and we're going to solve this one algebraically, and there are basically 2 ways to solve algebraically. One way is better if there's only 2 terms, and the other way is better if you have 3 terms, and that's factoring. This has 3 terms, but notice please with me that it is not in standard form. Since this is not in standard form, I need to get it into standard form. And I'm going to do that by moving across this 3. Okay? I'm just going to move it right across the equal sign so I can get it by itself. I'm going to subtract 3 from both sides is what I'm doing mathematically. So now I have 2x squared minus x minus 3 equals 0. Now I have this in standard form. And now I'm going to use a method that's called the AC method to solve this, okay, and to get this by itself. It starts with making a big old X right here and doing what I call prep work. The prep work is this. Whatever my A term is, it's going to go in both of these places, okay, both of these places. And then this is called the AC method because we take our A term times our C term. In this case, my A is 2, my B is -1, and my C is -3. So I'm going to multiply these two together and you get -6. Now instead of, I'm going to put the 6 up top. It goes right up top like a rainbow. But instead of putting the negative here beside the 6, I'm going to put it down here. And that tells me two things, okay? First of all, it tells me, since it's a minus sign, minus means difference, so take the difference, and that means the signs in here are going to be different. One's going to be a plus, and one's going to be a minus. And the other thing that it tells me is that when I'm going to make factor pairs in a minute, and I'm going to subtract. I'm going to take the difference of those two factor pairs and try to get my B term. My B term is -1, and the B goes below always. Okay? Now all of this is what I would call my prep work or my setup. Now then, what are the factors that give me 6? There's 1 in 6 and 2 times 3, and notice if I say 3 is the next one, it's a repeat. So I know that I'm finished. Now then, 1 minus 6, does that give me my B term? No. 2 minus 3, does that give me my B term? Yes. So that is it. This is my pair right here that I need to use. One's going to go in this one and one's going to go in this side. I forgot to bring down my 0. But how do you know which one goes where? The larger of the two numbers gets whatever sign B is. So this 3, since this my B term is a -1, my B goes with the minus sign. And my other term there, my 2 right here, goes with the other one. Okay? Now, we did take us a little shortcut because we put our A in both of these places. Now, you should be able to multiply these back out and end up with this one. So if we were to FOIL this, 2x times 2x, well, that's 4x squared. Well, that's not what we started with. So we took a little help, a little shortcut, by putting our A term in both of these places. And we did it because then we don't really have to think too much. Which one gets the plus sign, which one gets the minus sign. It doesn't matter. You just pick one for the plus and one for the minus. And or if this was a plus that was in the middle over here, they'd either both get pluses or both get minuses. So the last step I need to do now to fix that little shortcut I took is reduce it, just like you reduce fractions. Okay? Can 2 goes into both of these two, so this needs to end up being just x plus 1. That one will not reduce. It doesn't have any common factors, so that one stays just like it is. And so this then becomes, I'm going to set this equal to 0 and this equal to 0. X is a -1, or when I solve this one, 2x minus 3 equals 0. I got to add 3 to both sides, so then 2x equals 3, or x equals 3 over 2. Now you can go back in and check it and be sure that that's true. You could put a -1 in for this x and see if you get 3. And the same thing with 3 over 2. You can sub it in and see if you get it right. But let's keep in mind, please keep in mind your whole way through this, that what our goal is we are looking for where does this graph cross the x-axis. Because now you can sketch, you already know what the basic shape looks like this, and it's taller and skinnier because of this 2. You know your y-intercept is -3 because of this. Our c term is -3, and that's always your y-intercept. So now that we have these two places where it's going to cross that x-axis, here at -1 and at +1.5, you could draw a fairly accurate sketch of this function. And that's what we're doing, drawing pictures. Okay? So there's one. And I don't think I'm going to work through this one. You can work through this one and see if you can get the same thing. And then here's a little bit harder one right here. Here, this looks a little bit different. Again, it's not in standard form, so I just need to make it into standard form. And I need to get rid of this 2 because it needs to be ax squared plus bx plus c equals 0. Well, this doesn't equal 0. So let me subtract 2 from both sides. And notice what I end up with. 2n squared minus n minus 6 equals 0. Negative 4 minus 2 is negative 6. Now this looks just like the other. And I can do my little x factor method again. I know I'm going to have 2 binomials. They're going to equal 0. I'm going to put a 2n in both of these places. 2 times 6 is 2 times a negative 6 is a negative 12. I'm going to put the 12 up here. I'm going to put the negative here. Okay? And then my b term, which is negative 1, goes below. B goes below. Now what can I multiply and get 12? 1 and 12, 2 and 6, 3 and 4. Then 4 starts to repeat, so I'm done. 1 minus 12 is not 1. 2 minus 6 is not 1. But this, 3 minus 4, is 1. Since this was a minus sign, I know one's a plus, one's a minus. Which one gets which? The larger number gets whatever that sign is. So my 4 is going there, my 3 is going there. This will not reduce, but this will. 2n plus 3 equals 0. This one right here, 2 goes into both of these. So this one's going to actually end up being just n minus 2. So then n minus 2 equals 0. So n is equal to negative 3 over 2. N equals 2. And now you could draw a pretty accurate sketch of what this function looks like. All right? Now, let's do a completing the square. Completing the square is the least of all of them, my personal least favorite. But it is still another method that can be used to find the zeros, to find where x crosses the, to find where the function crosses the x-axis. So, here what we have right here, we have ax squared plus bx plus c equals 0, so it's in standard form. One thing that's important to know when you're completing the square is that this a term must be 1. If it's not 1, you must divide everything through. And you cannot divide it through if it's not equal to 0. Okay, so that's an important distinction. Now, I'm going to digress just a little bit. I'm going to go get a clean sheet of paper here. And I'm going to, again, show you what we are going to do. Okay, I'm just making up some numbers here. Let's say that I have x plus 5 squared. Okay? Now then, if I were to multiply this out, I would say, okay, this means I have 2 of these, x plus 5, and they're multiplied together. X plus 5. Now, I'm going to get some different colors. X times x. I don't want that big fat one right here. So x times x is x squared. Now I'm going to do x times 5 is 5x. Let me get a different color. And then we're going to do this 5 now. 5 times x is 5x. And then 5 times 5 is 25. So x squared plus 10x, because you combine your two middle terms, plus 25 equals 0. Okay, so this is what we have. So please notice what we started with. We started with this, a binomial. Bi means 2. It's got 2 terms in it. It's got an x, and plus, and a 5. And notice that it is squared. So this is called a squared binomial. And this whole process is called completing the square because we are going to make a squared binomial. And we're going to complete it. We're going to fill in all the little things that it needs to happen. I want you to notice a couple of things about this. Please notice our trinomial. This is a 10. Notice what it is in relation to this 5. Okay, how did we get from the 10 to the 5? We cut it in half. Yes? And then how did we get this 25 right here? We said 5 times 5, or 5 squared. Isn't 5 times 5 the same as 5 squared? So you squared that term to get it. So let's keep that in your mind, please. as we go back and do this example here. Okay? Here's a trinomial, and we want to take this trinomial and we want to make it into a squared binomial. So since I know that that's what I want to do, I'm going to go ahead and put my binomial, and I'm going to put my little square, because I know that's what I want to end up with. And then here's my equals to 0. Okay? When you complete the square, we remember back in our other example, we had x squared plus 10x plus 25, and our squared binomial was x plus 5, and it was squared. Okay? Notice, please, the relationship between this 10x and this 5. 10 divided by 2 is this 5. Okay? Now, then, please notice the relationship between this 25 right here and the 5. 5 squared, 5 times 5 is 25. So they are related, okay? So I need to do that when I'm completing the square. I need to focus on what my B term is, my middle term, and what my A is, and it has to be 1, remember. So I know that in the beginning I'm going to have an x. And because this is a plus sign here, this is going to be a plus sign here. Now I need to focus on only this term. And since I don't care about this 8 right now, let's move it over. Let's get it out of our way so we don't have to pay attention to it. So I'm going to get rid of that 8. I'm going to add 8 to both sides. So now then, I only have the x squared and the 6x. Let's go back to our example. What did we do to this 10 to get that 5? We cut it in half. So let's take our B term, our 6 here, and split it in half, and you get a 3. Okay? I had to bring my 8 down when I added it to 0 to both sides. Now then, I'm not done yet, because if I were to say x plus 3 times x plus 3, I would not end up with this x squared plus 6x. I'm missing a term. I'm missing some term right here. And then there's my equals 8 over to the side. I'm not thinking about it right now. I need to know what number that's going to be. And that leads us back right up to here. How do we get this 25? We said 5 times 5. So whatever is inside here, I need to square it. Okay? And I'm going to put that in my blank right here. 3 squared is 9. But if I put a 9 over here, I can't just randomly add a 9 in somewhere. I got to add it to the other side too. Plus 9. Okay? So now what I have is x plus 3 squared. And if you were to multiply that out, I'm going to do it just real quick. X plus 3 times x plus 3. That's x squared plus 3x. There and there. And then my 3 times x is 3x, and 3 times 3 is 9. X, and then these two terms get combined, so it gives you x squared plus 6x plus 9, which is what I have right here. So this trinomial right here gets replaced by that. They are the same thing, okay? And then what do I have still on the right side? X plus 3 squared, and then over here, down here, I had my 8 plus 9 is 17. Okay? Now, I'm not finished yet. I'm not finished yet because I have to get the x by itself. Remember, this whole purpose of this is to find out where my graph is going to cross the x-axis. Let's keep that in your mind, okay? So I need to undo everything being done to this x right here. I'm trying to get this thing by itself. It's being added by 3. It's being squared. So I need to get rid of each of those. Since I have parentheses, I can't touch my parentheses until last. So I need to get rid of that square. And how do we undo square? We take the square root. Remember, if you have to physically draw in that square root, this side is going to end up being a plus or a minus. Okay? And what does this square root do over here on the left? Nothing but take that square off. So now I have over here x plus 3 is equal to plus or minus the square root of 17. Is my x by itself? No, it is not by itself. How am I going to get it by itself? It's being added by 3, so I need to subtract 3. So now my final answer is going to be x is equal to negative 3 plus the square root of 17 or minus the square root of 17. And to get practical with you on that, what does that mean to us? Because our end game is, where does this thing cross the x-axis? Where do I need to put my dots? Well, I don't know what the square root of 17 is, but I know what the square root of 16 is, and it's 4. And 17 is a little bit bigger than 16, so guess what? This is going to be a little bit bigger than 4, and here's where you can take a little bit of help from your calculator, because you can actually take the square root of that, and that's 4.12. So what this practically means is x is going to be equal to a negative 3 plus 4.12 or negative 3 minus 4.12. And if I do that math right there, I'm going to get a 1 point. I'm going to have a dot over here at x equals 1.12. That's what this one equals here. And I'm going to get an x when I say negative 3 minus 4.12. It's going to be at negative 7.12. So I'm going to have 2 dots on here. One over here at 1.12, which is somewhere around about there, right there. And then over here at negative 7, down here someplace, is where my other one's going to be. Now then, as soon as you find the vertex, you could graph this thing and do a very good job of getting an accurate picture of this function. Okay? I hope that helps with completing the square. And the most important way is the quadratic formula. The quadratic formula can be used to find the zeros anytime, whether they're real, whether they have eyes with them, no matter what, you can use the quadratic formula, and you will be expected to commit this to memory. Okay? X equals negative b plus or minus, so that means there's going to be 2 of them. Just like we had in that last example, one's going to be a plus, and then you're going to subtract to get the other. B squared, the square root of b squared minus 4ac all over 2a. Remember, your ultimate goal is to find where this, if it crosses the x-axis, where does it cross the x-axis? So here's an example that we're going to do with this, just real quickly. And the first thing I need to ask myself is this in standard form? And it is not in standard form. So I need to get it in ax squared plus bx plus c equals 0 form. And there's my ax squared, there's my bx, but where's my c? It's across the equals. So I'm going to bring it across, change its sign. And now I end up with 3x squared plus 2x minus 7 equals 0. And now over here on my little scratch paper, here's my A, here's my B, here's my C. What does A equal? 3. What does that 3 tell us? It's going to be tall and skinny. Our picture is when we get there. Our B is 2. Our C is a negative 7. What does that negative 7 tell us? Where this picture is going to cross the y-axis. That's our y-intercept. So you're going to have a dot there, and you know your graph has got to go through that point. Okay? So let's find our zeros. Where does this thing cross the x-axis? And to do that, we're going to use the quadratic formula. X is equal, x meaning the solution, is going to be equal to a negative b plus or minus the square root of b squared minus 4ac. All of that's over 2a. Okay? Now this becomes just a substitution problem, a plug and chug. I would say in physics, x is equal to a negative b. My b is 2, so a negative 2 plus or minus the square root of 2 squared is 4 minus 4 times a is 3, c is negative 7. All of that's going to be over 2 times 3. So x is equal to a negative 2 plus or minus the square root of 4. Now then, negative 4 times 3 is negative 12. Negative 12 times negative 7 is positive 84. All of that's over 6. which is going to leave me, excuse me, with x is going to be equal to a negative 2 plus or minus the square root of 88 all over 6. Now, it would be lovely if we could leave that alone. But you cannot, because I can think of a number that goes into 88 that's a perfect square. And that number is 4. 4 times 22 is 88. So I've got to take that 4 out. What's the square root of 4? 2. So I can reduce this down to negative 2 plus or minus 2 square roots of 22, because 4 times 22 is 88, all over 6. Now, it would be lovely if we could leave that, but we cannot, because it's got to be reduced. I'm going to change colors here because I'm nearly done. And I'm going to change to this purple. Okay. I see a common factor, 2, 2, 6. 2 goes into all of those, yes? So then this final result is going to end up being, when I take a 2 out of all 3 of those numbers, that's a common factor, I'm going to end up with a negative 1 plus or minus 1 square roots of 22. There's an imaginary 1 in front of there. And if you need to draw that 1 in to show you can see, that's fine. 3. Now, what does that actually mean? Because it actually asks us to find an approximate solution. So I don't know where that is on the graph, because remember, this is our end game. Where does that thing cross the x-axis? So I'm going to, in my handy-dandy calculator, I'm going to say, well, what is the square root of 22? It's 4.69, okay? And 4.690, actually. And it tells us to round it to the thousandths. So actually, my zeros are going to be at negative 1 plus 4.690 over 3, and also at x is going to equal negative 1 minus 4.69 all over 3. So you can actually put that in your calculator. Don't forget to hit equal and then divide by 3. So it's 1.230, 1.230, and the other is going to be negative 1 minus 4.690 divided by 3, and negative 1.90. So those are where my two zeros are going to approximately be. Now, this is an exact answer, and that's what you're going to be expected to give. But practically speaking, do you know where that is on the graph? No. But I know that this first one here, this one, x is going to equal positive 1.23, which is about 1 1/4. Here's 1, here's 2, which is about right there someplace. Okay? And then I know I'm going to have a 0 at negative 1.89, which is almost at 2. So it's right in here, negative 1.90 or thereabouts. And so now I can get a pretty good idea of what that sketch is going to look like. I truly hope this has been helpful to you and will help you get it. The last way to do this, of course, is graphing, using the graphing calculator. And I do just want to touch on the discriminant for a minute. I'm going to go back to the other page, because when we were working this out using the quadratic formula, we had to do the square root of b squared minus 4ac. Well, this, when you work that out, is actually called the discriminant. And the discriminant is not something that I would normally teach just by itself, but you have to find it anyway when you use the quadratic formula. I know it's kind of a weird term, a weird name, but it is defined as the square root of b squared minus 4ac. What's underneath here? And it's called the discriminant because it gives you information. It helps you. If the discriminant, this right here, and in our case, we had 4 minus 4 times 3 times negative 7. So that equaled a positive square root of 88. Okay? This number, this 88 here, is called our discriminant. And if this 88 is a positive number, if it's positive, that tells you two things. That tells me I'm going to have this graph, my picture is going to cross the x-axis in exactly 2 spots. And then you need to go about finding those 2 spots just like we did. In our case, it was like at negative 1.890 1.90 and also 1.23. Those were our two places. So we found about where that is. If the discriminant turns out to be any negative number, let's say -5, that means that you're going to have eyes, and your graph is not going to cross the x-axis. It's going to cross over here or over here, okay? It's not crossing the x-axis ever, okay? And then the third possibility is that that becomes 0. The square root of 0 is 0, and so this goes away. And if that's the case, then you're still going to have it. It's going to touch the x-axis, but only in one place, and it's not crossing over. It's only going to touch there. The graph is going to come, touch right there at that one spot, and turn back. So you're going to have one real 0. And so that's what this next slide is showing you. Now, that's not one of those things you're going to be tested on, but it does tell you. Okay, if it is 0, you've got one solution. It's going to touch that graph in one spot only. If it's greater than 0, you've got two real numbers, two different ones that are real numbers. And the last possibility is if it's negative, that means you have an imaginary solution. Okay, again, I hope this helped.